Welcome to Math TV with Professor V. It's Saturday, January 21st, 2023, and I dug up this cute little integral of the day for you all. We have antiderivative of the square root of 3 minus 2x minus x squared dx. So if you kind of run through mentally your list of all your integration technique options, coming up short on a lot of them, what we're going to go with is a trig sub. And to determine which trig sub is appropriate, we need to complete the square of the expression underneath the radical sign, so of the radicand. Let's do that off to the side. So we're looking at 3 minus 2x minus x squared. I'm going to take the negative out of the x squared and the 2x. And then I want to create a perfect square trinomial here, so I'm going to add 1. But remember, what I just did was add an extra -1, right, to this expression because that minus sign distributes. So to keep everything as it was, I'm going to add 1. Then basically I just added 0. No harm done. And I can combine like terms. Notice 3 and 1 will give me 4 minus, and then I have x plus 1 quantity squared. So we can rewrite this integral now as the square root of 4 minus x plus 1 quantity squared dx. And then if you'll remember, for the 3 cases when we do trig sub, this one's going to correspond with using sine theta. In particular, we're going to let x plus 1 equal to sine theta. If you need to review the trig sub cases and how to do them, I have the video lecture linked in the description box here. All right, and then before we continue, we have to figure out what dx is in terms of theta. So let's differentiate both sides of this equation here. So dx, derivative of the left-hand side is just 1 times dx, equals to cosine theta d theta. Great, so now let's rewrite this integral all in terms of theta. I have square root of 4 minus, now notice, instead of x plus 1 squared, I'm going to have 2 sine theta squared, that whole quantity. And then instead of dx, I will have 2 cosine theta d theta. Good? Great. Okay, let's clean up further. So we have here square root of 4 minus, I'm going to square all of 2 sine theta, making it 4 sine squared theta times 2 cosine theta d theta. And then we have to factor underneath the radical and clean that up. If you've done lots of trig sub problems, you're probably an old pro at this, but I'll do it off to the side here so we don't have to keep rewriting the whole thing. So I'm going to take the 4 out, that way I'm left with this just 1 minus sine squared theta, which is 4 times cosine squared theta, right? We're going to use our Pythagorean identity. And then now we're left with square root 4 cosine squared theta times 2 cosine theta d theta. And then if you'll remember, I'm going to take the square root here, so that's going to give me 2. And then this is just going to be plain cosine theta. I don't have to worry about the absolute values because we restrict theta when we make the substitution. So we have 2 cosine theta times 2 cosine theta d theta. Right away, let's take these constants out, so they don't bother us. So we have 4 times the integral of cosine squared theta d theta. All right, things are looking so much better. Now, you should just be on autopilot like a cute little math robot. The minute you see cosine squared theta or sine squared theta, you just use your half angle identity. So we're going to replace it with 1/2 times 1 plus cosine 2 theta d theta. You just got to put those to memory. And then 4 times 1/2, that's 2. Let's put that outside. And then now I'm looking at what's left over. I think we're ready to integrate, aren't we? Yes, we are. So we have 2 times antiderivative of 1 will just be theta. And then antiderivative of cosine 2 theta. You don't need to do a u sub because of the 2. Just divide by 2 or multiply by 1/2 and think, whose derivative did I take to get cosine 2 theta? Why, it was 1/2 sine 2 theta. And then don't forget your plus c. Okay, nice. And then let's distribute the 2 now. So this is 2 theta plus sine 2 theta plus c. And hold your horses, we can't box this answer yet because the original integral was in terms of x. So we have to go back there. How do we go back there? We're going to draw a triangle. Since we made a trig sub, remember we let x plus 1 equal 2 sine theta. That means x plus 1 over 2 is equal to sine of theta. So we can draw a triangle for theta that represents this. Cute little right triangle. Sine theta is the ratio of the opposite side over the hypotenuse. So here's opposite, here's hypotenuse. You can use the Pythagorean theorem to find the missing side. It'll be 2 squared minus x plus 1 squared. Oh, that's exactly what was underneath the radical in the original integral. So I'm just going to replace it with how the radicand was written at first, 3 minus 2x minus x squared. Okay, so let's see here now. Are we ready to go back to x land? I think so. 2 theta. How do you express just plain old theta by itself? Well, you're going to come right here to where you made that substitution. If sine theta equals x plus 1 over 2, that means theta is equal to sine inverse of x plus 1 over 2. As simple as that. So I'll write 2 times sine inverse x plus 1 over 2. Okay, plus, now sine 2 theta, notice I don't have a 2 theta triangle, I just have a theta triangle. So it is time to bust out our double angle identities. Do you remember what sine of 2 theta is? It is 2 sine theta cosine theta. Okay, so we're going to keep that 2 in the front. Instead of sine theta, I'm going to write x plus 1 over 2. Sine theta is x plus 1 over 2. And then instead of cosine theta, we're going to come here, use the triangle. Cosine is adjacent over hypotenuse. So there you have it. Adjacent, square root of 3 minus 2x minus x squared over hypotenuse. Don't forget your plus c. Can we clean up a bit more? This first term is as cleaned up as it gets. You can't do any sort of, I hope you weren't even thinking about canceling those 2's. This 2 is trapped here. It's part of the argument of sine inverse. So no. So I'm just going to write this again. 2 sine inverse x plus 1 over 2 plus. Now if I look over here, yeah, these 2's I can cancel out. I still have a 2 down here though, and then this x plus 1 up here. So maybe I'll write them together like this. X plus 1 over 2, and then square root 3 minus 2x minus x squared, and then plus c. And this is our final answer. I know, it's not the cutest little answer we've ever done. And it's strange because, you know, the original problem looked quite harmless, right? But that's the beauty of math. Sometimes the unexpected happens, but it's correct. I hope you enjoyed this little journey, this little integral this morning. Give the video a thumbs up, subscribe if you haven't already, and check out all the playlists on my channel. I have full video lectures for Calc 1, 2, 3, Pre-Calc, Trig, lots of stuff. And if you want to see what I'm up to, you can follow me on Instagram and TikTok at Math TV with Professor V. Take care, you guys.